Welcome to our last video for Chapter 5. We talk about density. This is the strangest picture. Take a close look at it. If you put Pepsi, pure, like not diet, just Pepsi, you can do this with Coke too, in water, it sinks. But look at the diet. It floats. It's all about density. Density is a ratio of mass to volume. Seems easy enough, right? Well, you can use this as your formula, density equals mass divided by volume, or you could just follow your units and make sure your units are where they belong. See, mass has a unit of what? Well, if you guessed grams, you're spot on, and the symbol we use for grams is G. Volume has a unit, in this case, not liters, but density is measured in milliliters, and the symbol's ml. So I could rewrite the density ratio above not as density equals mass over volume, but as density equals grams per milliliter. Density can be thought of as a ratio, just like I said, of grams to milliliters. And you can think about this visually by looking at particles in a box. So in the first box, well, we got to get the volume of the box. Well, the box happens to be 1 by 1 by 1 centimeter. So we can get the volume of the box easy peasy, right? Do you remember the volume? How to get the volume of a box? Well, if you guess length times width times height, you're spot on. So it's 1 by 1 by 1 centimeter, which gives us 1 centimeter cubed. Yay, we have the volume. Oh, but the units don't match. I have a centimeter cubed, and I'm supposed to have milliliters. Well, good news. The easiest conversion ever is right there. 1 milliliter is equal to 1 centimeter cubed. See? 1 milliliter, 1 centimeter cubed. It is the easiest conversion ever. So if I have 1 milliliter cubed, I can easily convert that to 1 centimeter cubed. See, because if I have 1 milliliter right here, up here, and I say I had 42 milliliters. If I had 42 milliliters, I can easily convert that to 42 centimeters cubed. So 1 centimeter cubed is the same thing as 1 milliliter. And I'm going to take that. So now that we've got the volume, let's take a look at the mass. Well, if we have each ball representing 1 gram, then how many grams do we have? 8 grams is correct. So we're going to take that 8 grams and put it there. I'm ready to now calculate the density, which is 8 grams per milliliter. Let's take a look at this box. Do you think the density is going to be more or less? If you said more, you're absolutely right. Clearly, they're packed in there a lot more tightly. The density is greater in this case because the mass is greater. Whenever this numerator up here, whenever this numerator is bigger, sorry, I was going to say greatly bigger, but whenever it's bigger than the denominator, the mass is going to be greater than 1. And if the numerator is smaller than the denominator, then we're going to have less than 1, because density is a ratio of how much crap you have packed into a certain space. The density of water is one of the important things you need to learn to speak chemistry, and I know it continues to go on and on. To form the basic skills to be fluent in chemistry as we move forward, there is a lot of stuff that you have to know. I get that. Water, and it's like most fluids, it depends on temperature. We're going to use the value of 1 gram per milliliter as our density of water. However, you should know that that's the density of water at room temperature, which is about 20 degrees Celsius. Water's strange in this part of the curve. Water is actually most dense, and this graph doesn't show it as well as it should, but at 4 degrees Celsius. And as water becomes even colder, its density goes down. No other substance does that. Every other substance, as it would get colder, all those molecules packed into that space would just get closer and closer and closer together, and water doesn't do that. Water's density at -20 is much less than what it is at room temperature or even at 4 degrees. Why would that be? And what effects does that have? One of the things that you can see about this is ice cubes float in your glass of water. Well, they float in your glass of water because they happen to be less dense than liquid water. Any other substance, if I took it solid and put it in its liquid, it would sink. Not with water. Nope. Ice fishermen are real happy about this, as are people who like to ice skate on actual lakes. What would happen if ice behaved like every other solid and sank in its liquid? What would happen to our lakes? From a chemistrian point of view, this is why ice floats. This first picture represents solid ice. And as you can see from the solid, there are not solid, don't have my pen today, I'm just kind of using the PowerPoint. The solid, the atoms are not packed in as tightly as they are in the liquid. So if you think about density as being a ratio of mass to volume, or the amount of crap packed in a certain amount of space, the solid has much less packed in to the same amount of space. Therefore, it is less dense. Can a bowling ball float? What do you think? Take a bowling ball, put it in water. Can it float? Well, it depends on its mass. This first bowling ball has a mass of 8 pounds. The 8-pound ball floats. Because remember, density is a ratio of, that's right, mass over volume. In this case, the density of this bowling ball, the mass is less than, so the numerator is smaller than the denominator, which gives us a number less than 1. And since water has a density of 1, the ball floats. A 14-pound ball, the density is equal to mass over volume. And with the 14-pound ball, the mass is greater than the volume, which means the result is greater than 1. And the ball sinks. So, why does the diet float and the regular can sink? Now's the time where we're actually going to start calculating density. The first thing I like to do, of course, after I read the problem, so if you want to pause the video so you can read through the problem, I get that. Anyway, the point is, after you read through a problem, it's a really good idea to sort of take inventory out of the problem to figure out what you have. So, suppose that a student finds that 23.50 milliliters of a certain oh goodness, I'm going to stop. You know what? Milliliters. I'm sure okay, got 23.50 milliliters. Let's start with that. Of a certain liquid weighs 35.062 grams. What is the density of this liquid? Well, I happen to know that density is equal to mass divided by volume. But what I really need to do is figure out, do I have mass and do I have volume that I can actually use in this problem? The 23.50 milliliters. The milliliters should be a clue that this is volume. Mass. Well, over here I have grams, so that should be a clue that this is your mass. Well, I've got mass, I've got volume, so I'm pretty sure I can solve for density now. I'm going to substitute these numbers in, so we have, let's see, oh, there we go, 35.062 grams for every 23.50 milliliters. And so now you just got to get out your handy dandy calculators, which I'm going to do, so I'm going to pause this. Okay, I do that and I get, let's see, 1.492. Oh, I better have a sig fig check here. Let's see, this one has 4 sig, this number has 4 sig figs, and this one has more than 4, so I need 4. I have 4. I just now need a unit. Well, the grams didn't cancel, and the milliliters, those didn't cancel either, so I guess my final unit's grams per milliliters, and I am done. Hey, do you think this will sink or float? Well, if you said sink, you're right, because if you recall, the density of water, I should have said, will this sink or float in water? I get that. Anyway, the density of water is 1.00 grams per milliliter at room temperature. Room's temperature, that's brilliant. Yeah, at room temperature. And this number we came up with is greater than 1, so this certain liquid will actually sink below the water. I know this next problem requires quite a bit of reading, so yeah, you might want to pause it so you can actually read through this problem, because trust me when I tell you, I do like this problem. From the information in the previous slide, the one piece of information that was truly important was the 55.54 grams. Oh, okay, well, there's other pieces of information over there that are important, but for right now, that's the piece of information I really need. Okay, so she put some water in a graduated cylinder, and she reads the volume as 44.2 milliliters. And I know this graduated cylinder doesn't exactly show the correct volume, so it was the best picture I could find, so, you know, bear with me. Okay, well, the point is, when you drop a medallion or you drop anything in water, and if it's more dense than the water and it sinks below the water level will, any guesses? Well, if you said the water level will rise, you are absolutely right. Okay, so the water level is 67.8 milliliters. So, how on earth are we going to figure out the volume of that ball? Well, if you said subtract those two numbers, you got it. So here we go. I'm going to put the volume of the ball. Oh, there's my pen. So the volume of the ball. We're going to take the first volume of 67.8 milliliters and subtract that from 44.2 milliliters. And that's going to equal, that gives us a volume of 23.6 milliliters. Okay, now, got to check your sig figs, and both of these have one decimal place. Since we're subtracting, we look at decimal places, and we're good to go on that. So the question is, what is the density of the medallion? Well, density is equal to the ratio of mass to volume. And do I have the mass? I do. That's what the 55.54 grams tells me. I have the mass. Do I have the volume? I have mass. Do I have volume? Yep, I just figured out the volume of the ball. Got it? Check. So yeah, I can calculate density. Let's go ahead and substitute our values in. 55.54 grams divided by 23.6 milliliters. Get out the handy dandy calculator, and we end up with a final volume of 2.35 grams per milliliter. Am I done? Well, I'm not sure. I had to check my significant figures. And then there's 3 sig figs down here, and there's 4 up here. So, yep, I'm good. I have 3 sig figs. The medallion is 2.35 grams per milliliter. So, is the medallion silver? No. Silver has a density that's way higher than 2.35. Yeah, that's more like aluminum. I think. But I know silver is much greater. I think silver is like 19, to be honest. I could look it up. Or you could, and let me know. A student wants to identify the main component. I'll try that again. A student wants to identify the main component in a commercial liquid cleaner. Oh, this is just like your lab. Well, almost like your lab. Anyway, let's see. 35.8 milliliters. So let's get these words out of the way and write down what we have. 35.8 milliliters. And the cleaner weighs 28.1 grams, and I need to know the density. Yeah, density, mass over volume, mass. Which one of these numbers is mass? Well, if you said grams, you win the prize. Yeah, it's grams. And then volume, milliliters is volume. Yay! You have to know that, folks. You do. Do I have mass? Yep. Do I have volume? Yep. Oh, good. Now I can just substitute in. So the density is going to equal, let's see, 28.1 grams divided by 35.8 milliliters. Getting out the handy-dandy calculator. And I end up with a grand total of 0.785 grams per milliliter. And the winner is isopropanol. Just kind of a strange thing to put in a cleaner, but okay. Let's try a little more difficult problem. Please take a moment and try this problem, because I'm not sure what happens, but students get this type of problem wrong all the time, and I'm not that nice of a teacher in that, so I wouldn't put a problem like this on the test and totally put it on the test. But you gotta make sure you understand how to do this. Okay, so mercury has a density of, let's see, 13.6 grams per milliliter. And I know that if I have grams per milliliter, that's density. But look, it even said density right there. So I'm going to write D equals, yeah. Okay, what volume of mercury must be taken to obtain 225 grams? 225 grams. And if I see the word grams, I'm thinking mass. Yeah. What volume? So I need to find the volume. And I know that the ratio is density is equal to mass divided by volume. I've got the mass. Yeah. I've got density. Cool. I can solve for volume. Sure I can. Okay, so I'm going to substitute in. I'm going to put it up here. Density is 13.6 equals 225 divided by volume. Algebraically, what is my next step, please? Anyone? Someone? Okay, good. Well, you need to times both sides by V. Yes, you do. Because if you think about it, if I do that, that makes this line extend. I've got a V in the numerator, V in the denominator, V divided by V is 1. Those cancel. And that leaves me with, and I'm going to switch, I'm going to flip-flop these two. So I end up with 13.6 times V equals 225. Now I can divide both sides by 13.6. 13.6 divided 13.6 divided by 13.6. Yes, those two numbers divide to make 1 and they drop out, leaving me with a variable all by itself. And I can now set the problem up to say V is going to equal 225 divided by 13.6. Let me pause the video, figure out what the answer is. All right, I ended up with a volume of 16.5. Let's see, what unit would mass have? Well, there's always a good clue in the density unit. The density was measured in grams per milliliter, so it's gotta be milliliters. Bingo. Now, does this make sense? something has a mass of 225 grams. 225 grams. I know mass goes in the numerator, and it's got to be over 16, sorry about that. Let me get my eraser out. Oh, eraser, you're somewhere around here. Eraser, oh, there you are. All right, get rid of that. Try this again. Get a pen. All right, 16. I almost did it again. 16.5. Okay, now, the density was 13.6. Clearly, that number's bigger than 1. And if I divide 225 by 16.5, I will definitely get a number greater than 1. Of course, you could go ahead and check it if you want. But yes, bingo, I have the correct answer of 16.5 milliliters, and my significant figures are correct. Now, here's a question for you. Do I judge my significant figures based on the density value of 13.6 or on the mass value of 225? I would do it on the mass value of 225 because the density of a liquid can be considered to be an exact number. It is basically a conversion number between grams to milliliters. So for every 13.6 grams of mercury, you have 1 milliliter of mercury. So this is more of a conversion factor, an exact number, so use something other than the density, like in this case the mass, to obtain your significant figures. This is your homework set. We'll be working on those in class tomorrow. And we're done with the chapter. The very next chapter we're going to tackle is Chapter 6, where we talk about the mole. Have a great night.